All right. Okay, guys, so we are going to be doing something that you have not done probably since the 6th grade. You learned it in the 4th, 5th, or 6th grade, and then you stopped ever using it again, and you were led to believe that that was the last time you would ever need it. Like all math we do in Canada, we teach you a little bit, and then we don't use it again for like 4 years. Instead of finishing off the topic all the way to the end when you first see it, we expect you to see it, use it, and then never use it again for another 4 years. Then, oh, remember this? We're at one of those points right now, okay? Before we go on, though, I have to do a little bit of definition work for you. The first thing we need to talk about is this term. What is a prime number? Somebody knows, Brianna? Something that can go into both. A number that can go into both numbers. Oh, you're thinking of what a factor is. Yes, that is exactly what a factor is. That's where we're going. That's where we're going to get to. But before we get there, we need to talk about what prime numbers are. Right. A prime number has only two factors, 1 and itself. So it's the only numbers that can go into it. And so now I'm going to keep that definition. Prime number is any number that has only two factors. Two factors are 1 and itself. Now, the problem with this definition is, what if you don't know what a factor is? Well, that's exactly what Brianna just told us. A factor is any two numbers we multiply. Because if you multiply those numbers, they will divide into the product. That's exactly what Brianna just said. So, everybody is cool with this, yes? All the prime numbers have the same amount of power in the math world. Prime numbers being the most powerful numbers in the math world, except one. There is a particular prime number that is the most powerful, and that is the number 2. 2 is the strongest. Does anybody want to guess why? No, it is the smallest. What was that, Brianna? Yeah, 2 goes in. It is the only even prime number. And because 2 is the only even prime number, it allows us to do a lot of math when we're using just the number 2. Okay? So what we're going to do is we are going to do a factor tree that Mrs. Bad Crumble taught you in grade 6. Okay? And it's really very easy, especially if you know your times tables. So a factor tree simply gets all the numbers that multiply to the number above it. All right? So we're going to start with 54. I need 2 numbers that will multiply together to make 54. Any 2 numbers that will do that job. What are they? 6 and 9 will work. So we make our tree, 6 and 9. Everybody cool? Easy peasy. Could I have written 9 and 6? Yes. Everybody good? And then we keep going on each branch until we get to a prime number. Okay? So are there 2 numbers that will multiply together to make 6? What are they? 3 and 2. 2 and 3. Now, are those prime numbers? Yes. 2 we know is a prime number. It's the strongest one, so I'm going to circle it. And 3 is a prime number because 3 only has 2 factors, 1 and 3. Agreed? Okay. And I'm circling them because that's where I stop. What about 9? 3 and 3. 3, another prime number, and 3, another prime number. Everybody cool? That's the factor tree. You all should have seen that in about grade 6. Yes? You've all seen a factor tree, right? We're going to go one step further with that. In the 9th grade, actually before the 9th grade, the 8th grade, you learn to deal with exponents. Yes? So this is saying that 2 times 3 times 3 times 3 equals 54. Everyone agree? Now, let's write this out as exponents. How many 2's are there? 1, so there's a 2, times how many 3's are there? 3. So 3 cubed equals 54. Everybody cool with that? 3 cubed is 27. 3 times 3 times 3 is 27. 27 times 2 is 54. We're good, yeah? Okay. Now you guys do the same thing over here with 162. Now 162 is a big number, right? And we're trying to get to prime numbers, yes? So soon as I see that 2, what's a number I could use? 2, because it's even. And I know 2 is a prime number, right? Now I know I want my branches to end at prime numbers. So I'm going to go ahead and I'm going to write a 2 over here. Because that's where it's going to end. Now what does that leave me with? 2 times what? 81. Now what? That's not a prime number, is it? So what do? I continue. 9 and 9. Are those prime numbers? What are they? 3, oh, there's a prime. 3, there's a prime. 3, there's a prime. 3, there's a prime. Everybody agree? And then how would I write that out? 2 times 3 to what power? Can everybody make a factor tree? You all remember how to do this from grade 6, right? Some of you from earlier than grade 6, but you can all do this, yeah? And this is where it ended, isn't it? You made a bunch of factor trees, Mrs. Bagcrum gave you a test, and then you moved on to the next math topic, right? We're going to use these to do something now, okay? Highlight or underline this term, greatest common factor. And right below that, actually, let's go right above it, GCF. That is the abbreviation for it. Okay? Now the GCF is exactly what it says, greatest common factor. What does greatest mean in math class? Biggest. Furthest to the right on the number line, correct? What does common mean? That's one word for it. In both. Right? Adam and I share in common the fact that we are both holding a writing utensil in our right hand. Understand? Now, some of you are freaks and have your writing utensil in your left hand. Not you. Any left-handeds in here? None? Well, that's weird. Usually there's 1 or 2. Then I get to make fun of them. I'm not really making fun of left-handed people. I'm not. But they will disappear soon. Left-handedness will be extinct. Much like blonde hair. True story. And redheads. Eventually, they will be bred out of the population. And everyone will have brown hair. If we were left alone. Yes, Brianna? Of course. Okay. So, greatest, biggest number, common, shared. So, greatest common factor must be, and a factor is any number that multiplies into another number. So, the greatest common factor is the largest number which, not can be divided into a pair of largers, or a pair of numbers. So you guys did this when you were kids with little tiny numbers, right? For example, what's the greatest common factor of 6 and 9? 3, because 3 times 2 is 9, 3 times 2 is 6, 3 times 3 is 9. 3 is the biggest number that goes into both of them, right? And you all learned to do that in grade 6, and you all learned to do that because it was helpful with things like fractions, making fractions simpler, making fractions bigger. It was helpful with things like that. It serves a purpose in higher level math as well, but you guys haven't tried it yet. I'm going to show you how to do that with big numbers, and that's what we're going to do right here. Prime factorization. Now I'm going to highlight prime factorization, and I'm going to highlight that and that, because everything that's in yellow right now is the exact same thing. This is prime factorization because we've only used prime numbers. Everybody understand? Same thing here. 2 and 3 are both prime numbers. Cool? Okay. So the GCF can be found with prime factorization by, now this is tricky. You've got to read this and actually understand what's happening here. A GCF can be found using prime factorization by using all the factors that appear in both lists. Okay? So the first number had these factors, right? I had 2 times 3 cubed, right? And the second number had 2 times 3 to the 4th, right? So the GCF is all the factors that appear in both lists. Is there a 2 in both lists? Yes. So the GCF has to have a 2 in it. Cool? Is there a 3 in both lists? How many 3s appear in both lists? How many 3s are in this list? 3 of them. How many 3s are in this list? 4 of them. So how many 3s appear in both lists? Just 3. So that is our greatest common factor. Does everybody understand how it works? We're going to practice a bunch. Don't worry if you're a little hazy. But does everybody understand what I'm saying? You compare only what is common to both of them. Everybody got it? Okay. This is used to simplify square roots. That's what we're going to use this for. The next thing we're going to talk about is the lowest common multiple, which is an LCM. And this one's trickier. Okay? The lowest common multiple is the smallest number your whole group will divide into. And you guys have used this in fractions. This is how you do lowest common denominator. So you actually have used this one in the past when you're adding fractions. Like if you got to do 1 half plus 2/3, you know it's got to be over 6. Because 6 is the lowest common multiple of 2 and 3. You guys remember this, yes? Again, we don't do anything differently, but we can use it with big numbers like 54 and 162. And we find the LCM. Now this is where it gets different. Please notice in GCF we use all of them in both lists. Cool? For LCM, we use all of them, not just ones that are common. We use all of them, but we don't repeat. So here's what I mean. You guys, we've already done the GCF. We had 2 times 3 cubed, 2 times 3 to the 4th, and we checked. There's a 2 in both, and there's 3 3's in both. So my answer is 54 is the GCF. And that makes sense because 54 is a factor of 54, isn't it? 1 times 54 is 54. Everybody good? So now let's do the LCM. I had 2 times 3 cubed and 2 times 3 to the 4th. I count everything, but I don't do any repeating. So, if I count this 2, how many times do I need to count it? Once, because it would be repeating. So I got a single 2. Understand? This group covers 4 3's. I have to count them all once. Do those 4 3's cover those 3 3's? Yes, because I don't want to count anything twice. So I'm done there, and it's 162. And that makes sense because 162 times 1 is 162. So that's the lowest common multiple because 54 times 3 is 162. Is everybody good? It's something you really need to practice before you go too much further. And when you turn the page over, we're going to do 4 of them. Okay? So let's turn the page over onto your page 69, my page 75. And let's work this one together. And then I'm going to let you guys do the next 3. Okay? So the first thing to do is take 36 and break it down. Does it matter how you start? So somebody tell me 2 factors of 36. Great. Almost everybody says 6 and 6. Could I also have done 9 and 4? Could I also have done 12 and 3? Could I also have done 18 and 2? Yes. Because we're going to continue the tree until it ends. Right? So what would be the next one from 6 and 6? Because are either of those prime numbers? No. So we got to keep going. What would be next? 2 and 3. Are they prime numbers? So I'm going to stop and circle them because I know they're important. 2 and 3. And then I'm going to write it out properly. How many 2's do I have? 2 squared times how many 3's do I have? 3 squared. Is everybody cool? Now just stop for a second. I want to show you something. Don't write this down. If I had gone a different path, 9 and 4, 3 and 3, 2 and 2. Do I end up with the same? If I had done 36 as 12 and 3, stop at 3, 4 and 3, stop at 3, 2 and 2. Do I end up the same? Why am I Why am I showing you this? Because it doesn't matter what way you do it. Some kids, when we're doing this, are like, well, you did your tree differently than mine. Does it matter? No. Because you're going to end up at the same spot, right? It would be like I said, hey, meet me at the Orange Julius Dairy Queen in the mall at 5:30. As long as you're there at 5:30, is everything cool? Do I care how you got there? Do you care how I got there? As long as we're there, and I buy you a hot dog and a triple berry smoothie, we're in business, right? Of course, who wants a triple berry smoothie? Barf. You obviously want the pina colada smoothie. That's the best. In America, pina colada Slurpees. Yeah. And you haven't lived till you've had an American Slurpee. They're so much better than ours. But you have to be careful because they come out like a fire hose because they're carbonated. So you got to hold your cup really tightly because my kids do it all the time. They just hold their cup, think it's going to come out real slow like Canadian Slurpees. Then they hit the tap, and then I yell at them. It's a true story. Ask Elle. She's American. Slurpees come out fast, don't they, Elle? Oh, Elle, you're killing me. I drank so many pina colada Slurpees this weekend or this last week. Every 7-Eleven we drove past. Going for a pina colada Slurpee. My kids are always like, why do you get all the Slurpees you want? Because I make the money. Can I have a Slurpee? No. Exactly. Although my daughter was paid like $3,000 for one day of work when she did her commercial. So if she actually starts getting that work, I'm going to have to change that argument. But so far, I don't have to. So everybody cool with the 36? Okay, now you guys go ahead. Let's do 120. Because it doesn't matter how you start. I know what I'm going to use for 120. You guys may use something different. I'm going to go 12 and 10. What did you use, Brandy? What? 8 and 15? It's crazy talk. 8 and 15. Most people say 3 and 40 there, but okay, 8 and 15. Who used something different than 8 and 15 and 10 and 12? Did anybody use 3 and 40? 2 and 60? 2 and 6? 2 and 5? Can I stop there? No. 2 and 3. Now I get 2. How many 2s? 3 of them. How many 3s? 1 of them. How many 5s? 1 of them. Can everybody get to there? Everyone is to there? Okay, that's grade 6, right? Let's do the grade 10 part of it now. What's the GCF? The GCF means we need everything that's in both. Everything that's in both. So, is there 2 in both? Right. How many 2s are here in black? 2 of them. How many 2s are here in red? So how many 2s are in both? 2 2s. Everyone agree? Everyone okay? There's 2 2s there, and there's 3 2s there. So, Parm, you have 2 2s. Put up double V's. You got 2 2s, right? I got 3 2s, right? 1 2, that's in both. Second 2, that's in both. Do I count this third 2? No, because I'm only counting everything that's in both of them. You understand? Okay. Is there a 3 in both of them? How many 3s? 1 3 is in both of them. Because that guy's got 1 3, that guy's got 2 3s. So there's only 1 3 that's in both. Cool? Any 5s in both? No. So what's my GCF? What's 2 squared? 4, and what's 4 times 3? 12. Done. Cool? Everybody good? Okay. Now let's do the LCM. The LCM is everything once. Once is key. So, is there a 2 in both of them? Right? How many 2's do I have to count to cover all the 2's at least once? 3 of them. Right? Because those 3 2's cover those 2 2's. Got it? How many 3's do I have to count to cover all the 3's once? 2. Because these 2 will cover that 1. Everybody cool? And do I count the 5 this time? Do I count the 5 this time? Why? Because I count everything once. So what's 2 cubed? What's 2 times 2 times 2? 8. Right! What's 3 times 3? 8 times 9 is 72. And 72 times 5 is 360. Everybody good? Everybody good? Okay, you guys try 18 and 24. I'm going to turn the screen off, and I'm going to continue to work. So if you watch the video later tonight, you'll actually see what I did. But I'm going to show you guys just the answers in a minute. Brandy. Oh, yeah, sure. Two cubed is 2 times 2 times 2, which is 8, right? 3 squared is 3 times 3, which is 9, right? And then 5. 8 times 9 is 72. And 72 times 5 is 360. Because 70 times 5 is 350, and 2 times 5 is 10. 350 and 10 is 360. Got it? Oh, you just did 3 cubed? Yeah, you just counted too many 3's. Because you only count everything once. Okay, everybody ready to try the next one? Okay, go. Stupid remote doesn't work. There we go. Just do B for now. Wake up. Swish and flick. Wingardium Leviosa. Expelliarmus. So everybody should be here now, right? Everybody got it? Okay. The GCF, I count everything that's in both lists. How many 2's are in both lists? Just 1 2. Because this guy's got 3 2's, but this guy can only cover 1 of them. How many 3's are in both lists? 1. Because this guy's got 2 3's, but this guy can only cover 1 of them. So my GCF is 2 times 3, which is 6. Everybody cool? My LCM, I count everything once. What's the maximum amount of 2's I can count? 3, because that 3 will cover this guy, won't he? So I got 2 cubed. What's the maximum amount of 3's I can count? 2. 3 squared. 2 cubed is 8. 3 squared is 9. 8 times 9 is 72. Is everybody okay? If I were a betting man, I would say the only place you're having trouble is here. I would say you're okay to find your factors. You're okay to do the GCF. This is what previous classes of mine have trouble with. And yet nobody wants to practice it. Everybody thinks that, oh, I'll get it, but I don't have to practice it. Everybody okay? All right, let's move on. Let's do C, 45 and 75. I'm going to turn off the light. You guys go ahead and try the factoring. I'll turn it back on in a moment after we've factored it. And remember, if you watch this later tonight, all my factoring is on the video. I'm still recording. I'll wait a second for you guys to get C factored, and then I'll turn the light back on. I need that book right there. Okay. So, here are your factors. Did you do it right? Okay. So my GCF counts what? Everything that's in both. Is there a 3 in both? How many 3's appear in both of them? One 3, right, Robbie? Because this guy has 2, but this guy only has 1. So there's a 3 that's in both of them. How many 5's appear in both of them? 1. So the GCF is what number? 15. Cool? All right. The LCM counts everything once with no repeating. How many 3's will cover all the 3's? 2 3's. How many 5's will cover all the 5's? 2. 3 squared is 9. 5 squared is 25. So it's 225. Is everybody good? Okay. Do D. Maybe it'll turn off for me. Maybe it'll turn off for me. righty. So my GCF is what? Everything that appears in both. What's the only number that appears in both? 7. Right? Oh, I shouldn't have made that green. 7. Now, my LCM is everything counted how many times? Once. So how many 2's do I need to count? 2 2's. How many 3's? 1 3. How many 5's? 1 5. And how many 7's? 1, because I don't repeat it at all. And that answer, what's 2 squared? 4 times 3 times 5 times 7. 4 times 3 is what? 12. 12 times 5 is 60. 60 times 7 is 420. Is everybody cool? Yes, everybody knows, Sean. Everybody knows, Sean. We're just in a math class, so we just consider it a number, not 420. Okay? Everybody good? Okay. Now, what do you think happens if another number is added to this? You do the same thing. So what if I told you it's not just 35 and 84, I'm adding into this 64. What do I have to do to this group right here? I got to make a tree for 64 then, don't I? Which is 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. 1, 2, 3, 4, 5, 6 2's. Does that change the GCF? Yeah, it does. Because what's the only number that's in all of them now? When I'm working with all 3, what's the only number that's in all of them? 2. Wait a minute, 2's not in this one. So is there a GCF? No, there's just 1 that goes into everything. You with me? So its GCF is 1. Because there isn't a number that works. Can I get an LCM though? Yeah. What's going to happen to do my LCM? How many 2's do I need to count? 2 to the 6th. And then I count everything else, times 3, times 5, times 7. And that's a gigantic number that I'm not even going to write out because I can't do it in my head. Well, I probably could. It's 64 times 3, which is 180, 192. 192 times 5 would be 1,000 minus 40 would be 960. 960 times 7 would be 6,300, 6,720, 6,720. Everybody good? Now, guys, I know this seems like, wait a minute. You really didn't add anything from the 6th grade here. But also recognize this is only the 2nd day of this unit, right? Whereas in the 6th grade, this was the end of the unit. We're going to take what we're learning today, we're going to use it over the next couple of days to do some higher level math, okay? But I can't go on if you can't do this really effectively, okay? So I'm going to stop now. You're going to open up your blue workbook to page 140 and 147, which is the next page in it. 140 is down the left-hand side. 147 is down the right-hand side. Okay, and you will notice that on the 147 page, there's a little bit of review of measurement stuff, because that's coming up in your cumulative on Thursday. Okay? Now, it's only 12:30. Class goes till 1:05, and I have a trigonometry test to give back to you. I want to give that back to you at around between 10-2 and 5-1, so we can have a quick look at it. Because some of you did really well and some of you did kind of poopy on it. And you've got a chance to fix it up on Thursday. Okay? Everybody understand what they need to do right now? You're working on out of your workbook. It is page 140 and 147. But there's no page numbers in your actual book, because I'm an idiot. Then we're going to look at your trig test at around 12:50. And then don't forget, you have your cumulative on Thursday. And that cumulative is how you improve your marks on either Unit 1, Unit 2, or possibly both. Okay?